As part of a race team, we use a vast array of technology to help us understand where our cars are at mechanically and where the stress levels are. Being able to accurately predict the mechanical future of any vehicle is a huge advantage. This concept isn't as far-fetched as it sounds, and it doesn't involve crystal balls, tarot cards or tea leaves. It's something Komatsu does right here in this lab.
Using a scientific methodology, Komatsu has changed the way machinery is monitored and maintained.
With some help from 21st century chemistry and a laboratory filled with the latest scientific tools, a machine's future can indeed be predicted and managed for the better. So how is this possible? Well, to begin with, all it takes is a sample of your machine's engine, transmission or hydraulic oil or its coolant.
Thousands of samples arrive every week at 3 Komatsu labs across the country, including this one here in Queensland.
Each sample comes with its own sample information form. This is all the equipment details, including serial number, unit number, component and machine hours, as well as the fluid details such as brand, type, grade and fluid hours. All this vital information is factored into the final test results.
Some machines are assessed weekly, so this traceability is vital to ensure results are allocated correctly and trends identified and evaluated by the analysts.
Tests on oil samples are conducted according to the component type. So the oils from hydraulic, transmission, engine and gear systems all have specific tests. Each sample for the analysis is allocated and registered to the unique sample identity number for tracking.
Prior to the testing, the samples are shaken. Wear particles, contaminants and additives that have settled at the bottom of the sample bottle or floated to the surface are suspended back in the sample fluid. Samples are poured into the test tubes and vials in preparation for forthcoming tests. For some of the tests, the oil samples need to be diluted with kerosene to make a lower viscosity solution. The Janus auto diluter creates these diluted samples. It uses disposable probe tips to avoid any cross-contamination. With the sample prepared, it's distributed around the lab for a series of primary tests. We'll look at those in detail in other modules, but in summary, they include ICP analysis, which looks for elements in the fluid, the particle quantifier, which provides a measure of ferrous debris in the lubricant, the sputter test examines the presence of water in the oil, FTIR analysis is used to determine soot, oxidation, nitration and sulfation levels in used oils. Viscosity determination checks for changes in the thickness of oils. This occurs as a result of contamination or chemical degradation of the oil. Particle count measures the cleanliness of oils. And fuel dilution, which checks for fuel presence in engine oils.
There's also a suite of secondary oil analysis tests. These generally happen if results from the primary tests need further evaluation or if requested by the customer.
These include tests to measure the acid number, base number and moisture content in the sample lubricants.
Engine coolants provide another window into an engine's health. Coolants protect systems from overheating or freezing and guard cooling systems against corrosion.
A range of tests and equipment help monitor the condition of engine coolant. They look for glycol levels, measure pH levels and conductivity, check the colour and clarity, as well as look for any visible solids in the coolant. When all the various tests are completed, the data is sent straight upstairs to be assessed. The sample data is reviewed against the previous component trend data. The technicians are looking for any changes or any anomalies that have been discovered. It's these changes that reveal the secret to predicting the state of the machine. For the Komatsu technician, this data paints a detailed picture of the operational status of your machine and what needs to be done to keep it running at optimum levels.
There are 5 levels of reports in the Komatsu's CMS's alert management system. Obviously, a normal result means the future looks bright for your machine. An action alert highlights maintenance that will be required at the next service event, whilst a critical alert requires immediate action in order to prevent major failure. This allows you to repair a component rather than replace it, which is far more economical in terms of time and costs.
Each customer tells the CMS team how they would like to be advised about machine health issues. For example, a customer can request a normal report be emailed to an asset manager. But with a critical issue, an email is sent to the asset manager, a text message to the plant manager, and a phone call to the maintenance supervisor or even the machine operator.
With the warning provided by CMS's extensive analysis and reports, you avoid downtime and know when to maintain and fix things. And this is where Komatsu's condition monitoring service's ability to predict the future saves you a whole lot of time and money.